Hello students, how are you? So today's topic was again differential equation class 12 PYQ plus some important question, okay, and this is part 2 important. In yesterday's class we discussed around 7 questions. You can visit in that video. Understood? Now we further move towards next questions. So give me a minute. I write the question on whiteboard. Okay. So the first question of our day is to find the solution for the differential equation cos of x 1 plus cos y dx minus sin of y into, wait a minute, into 1 plus sin x dy times equals to 0. Now you can take a pause of 30 seconds and think how to solve this question. Okay. Then we move toward solution for this question. So you take the time of 30 seconds, then we move toward our solution. Okay. So first we separate the variables. 1 plus cos x times 1 cos y dx equals to sin y 1 plus sin x dy. Okay. Then what we get after the variable separation, we get cos of x 1 plus sin x dx and sin of y 1 plus cos y dx. Okay. Now we do further move to this question by variable separation. Okay. So we take t, or let's say t equals to 1 plus sin of x here, and here we take v 1 plus cos y. Okay. Now we differentiate both sides with respect to x. So we get dt cos of x dx, because the differentiation of sin x is cos x, and here we move and differentiate both sides, we get minus of sin y into dy. Why? Because differentiation of cos y is minus sin y, and remember this equation is 1. Now we substitute the above values in equation 1. Wait a minute. Let me fix the screen. Okay. Let me fix the screen. Okay. So, putting our values of t comma v in equation 1. What we get? Can anyone proceed further? So we get here 1 of t, because in the place of 1 plus sin x we are writing t, okay, and for cos dx we are writing dt, equals to 1 by v. For 1 plus cos y we are writing by v, and further we are writing here dv. Why dv? Because dv is equals to minus sin y dy, so we can write dv equals to sin y dy, okay, and in place of sin y dy we put the value of minus dv. Now we integrate both the sides. Here integration done with respect to t, and here integration done with respect to v. So we get log of t minus log of v plus c. That can be written as log t plus log of v equals to c. Since the value of t is what? 1 plus sin x. So log 1 plus sin of x plus log 1 plus cos y is equals to c. Okay. And this is the question of general solution. So in this question we don't eliminate the value of c, and this becomes okay, c can be any constant now. So can we assume in the place of c log of k, where c is our log of k, because this is constant and we can assume any constant in the place of this. So what we get? 1 plus sin of x into 1 plus cos of y, which is of log of whole log 1 plus sin x into 1 plus cos y log of k. And why we are writing like this? Because we know that log x plus log y is always equals to log of xy. Done. Now we eliminate the both side, log both side. So we get, after eliminating log both the side, we get 1 plus sin of x 1 plus cos of y is equals to k. This is our final solution. Okay. Okay. Now take a 1 minute and try to see what we have done in this question, and then we move towards next question. Okay. Meanwhile, I am choosing next question. So be with me. Okay, now we are moving to next question. Second question. And this is quite simple one, and this was asked in the previous year for 2 marks, which is dy by dx 3 e2x 3 e4x ex plus e minus x. Okay, simple one. For this we write, first take common of e2x and 3 of e2x. Here 3 e2x and 3 e2x. From both sides we taking common. So we get e raised to the power 2 of x. Can we write e raised to the power minus x as this? Okay, which further can be written as e raised to the power 2 of x 1 plus e2x plus 1 e raised to the power x. This can be written like this. Okay, and this becomes 3 of e3x 1 plus e2x by 1 plus e2x, and this part can be cut, common part. So what we get, dy by dx 3 of e3x. Now integrating both sides, that is the d of y, integration of 3ex 3x dx, and what we get y equals to 3 into 3 3 e3x by 3 plus c. Okay, and this can be cut, so our solution becomes e3x plus c. Okay, and this is our final general solution, and we know that integration of e raised to the power ax dx is always equals to e of ax, there is error in this part, wait a minute, let me erase. Okay, integration of e raised to the power ax dx is e ax by a plus c, and here our a is 3 in this question, and this is our final solution. Okay, now take a pause of 30 seconds and try to analyze this question, and now we are moving to next important question in this chapter. Okay, now we are moving to the next question, which is third one. So the question is to solve differential equation e raised to the power x under root 1 minus yx square dx plus y by x dy times 0. Okay, So can anyone guess how to approach in this question? You have the time of 30 seconds to think over it, and then I start solving the question. Okay. Think about it. Then I start solving next question. Okay, I'm starting to solve the question. Okay, to solve differential equation, e raised to the power x under root 1 minus y squared dx plus y by x dy equals to 0. Okay, this is our differential equation. So how can we solve? So our e raised to the power x under root 1 minus y square dx plus y by x dy is 0. Okay, this further can be written as under root 1 minus y square dx minus yx dx. Okay, now we separate variable. Now we write this ex dx x together and minus y under root minus y square dy together. So-called variable separation of variable to get our required solution. And this can be written as x ex dx, which is equals to minus y under root minus y square dy. Okay, now we start integrating this, and we assume this as 1 and we assume this as 2. Actually we are applying the concept of islet. And what is the islet? Integer, logarithmic, trigonometric and exponential. Okay, and we start integrating both the sides. Okay, so what we get x times e f x minus differentiation of x here with respect to x, e of x times x dx, and integration under root minus y under root minus 1 minus y square dy. Okay, which further can be written as x ex minus integration ex dx integration of minus under root 1 minus y square dy. Okay, and this further can be written as x ex minus ex under root minus y under root 1 minus y square dy. Okay, now moving further in this question, we assume t equals to under root minus 1 minus y square. Okay, now we are differentiating both the side with respect to y. We get dt of minus 2y dy. Okay, just we differentiated the both sides. So can we write minus dt by 2 dt by 2 minus y dy. Okay, and we name this equation 1. So in the next part we put values given above in equation 1, okay, in equation 1, okay. So what we get x ex minus ex integration. Now see carefully, minus y dy, minus dy here is common, so can we write here half by dt in the place of this, and under root 1 minus y square, and 1 minus y square is what? It is t, okay. Now see, can we write half of integration t raised to the power minus 1 by 2 dt. Now integrating, we get half of t raised to the power minus 1 to minus 1 by 2 plus 1 minus 1 by 2 plus 1, okay. S is our integrating constant, integration constant, which further can be written as 1 by 2 t raised to the power 1 by 2 1 by 2, okay, plus c. Now 1 by 2 is common, so you can cut this part. We again get under root t plus c, and this is equals to x ex minus ex, where c is our integrating constant. Now what we assumed above the value of t, this is nothing but under root 1 minus y square. So here we put value of t, which is 1 minus y square plus c, which is equals to x ex minus ex, which further can be written as x minus 1 under root 1 minus y square plus c, and we taken ex common here from left hand side, and we get the final solution, which is x minus 1 into equals to under root 1 minus y square plus c, which is our general solution. Fine. Now we move towards next question. That was the asked in the previous year, most important question. Until now we have done 3 questions. So take a 1 minute and try to analyze what we have done in this question. Then I will move towards next question. Okay. I'm showing you the question from here what we have done. In this question. So we started from here, keep moving. We got our solution, ex x minus 1 under root 1 minus y square under root 1 minus y square plus c. Now our next question is fourth one. This is important question, okay, and this is little bit moderate side, not easier, and it can come in 4 to 5 months easily, and it is horrible also. So be with me with this question for next 10 to 10 minutes to solve. to solve differential equation one plus e raised to the power 2x d of y plus 1 plus y square ex dx is equals to 0 under the condition x equals to 0 and y equals to 1. Again, take a pause of 1 minute and try to analyze how we approach this question. Very important. It is quite important one. Okay. Important issue. We have 1 minute. Try to analyze. Try to analyze how we approach this question. Then, can we proceed to the solution? Okay. So, we have given equation. Wait a minute. 1 plus e raised to the power 2x dy plus 1 plus y square ex dx equals to 0, which further can be written as 1 plus e 2x dy minus 1 plus y square ex dx. Okay, now can you tell me how can we proceed in this question? Again, we separate the variables, like writing dy 1 plus y square together and writing 1 plus e 2x ex dx together. So we get d of y 1 plus y square minus ex 1 plus e 2x dx. Okay, which can be integrable both the side. Okay, so what is the integration of 1 plus 1 plus y square? It is tan inverse y. Isn't it? And this is e of x 1 plus e 2x dx. Okay, now what we do, we again substitute, we again proceed this question through substitution. So we substitute t equals to e raised to the power 2x. Now differentiating both sides with respect to x, what we get? dt e 2x by 2 into dx. Okay, sorry, there is one mistake. I'll let you know. We assume We assume t equals to ex, else we not get the question or solved. So we let t equals to ex. Then what? And then we differentiate both the sides with respect to x. We get d of t ex dx. Okay, dt equals to ex dx. And we name this equation as 1. Now see what we do. We substitute the value of t as ex and ex dx as dt. So here is common. You can see. Can we put dt there? And here is the ex. So can we write as dt is to the power 2? And then we integrate our equation with respect to dt. So see in the next step how this can be done. Putting above values in equation 1. What we get? Tan inverse y integration dt 1 plus t square. Okay. Now can you tell me what is the integration of 1 plus t square with respect to dt? Which is minus tan inverse t plus c, है ना? And this is our tan inverse y, है ना? हम ऐसे कर सकते हैं ना? अब आगे कैसे प्रोसीड करेंगे? कैन यू टेल मी? वेट अ मिनट. तो बता सकता है हाउ कैन यू प्रोसीड? तो अब हम क्या करेंगे? जो हमने t की वैल्यू ली थी, we put in this equation. So what is our t? It is ex. So this is tan inverse y equals to tan inverse ex plus c. Now the main part of the question. हमने कल पढ़ा था कि जब भी हमें कंडीशन गिवन होगा, like here what we are given, x equal to 0 and y equals to 1. जब भी हमें ऐसे कंडीशन गिवन होगा, हम c को हमेशा एलिमिनेट करेंगे, आर्बिट्रेरी कांस्टेंट. हमने इस टाइप के 2 क्वेश्चन किए थे इजी लेवल पे इन द प्रीवियस क्लास. ओके, सो सी हाउ कैन वी एलिमिनेट. एंड the given condition is y equals to 1 when x equals to 0, है ना? So see what we do. Can anybody guess how to approach? Again take 30 seconds और आप एनालाइज करें कि हम इसको कैसे प्रोसीड करेंगे. जस्ट थिंक ऑफ इट. Then I will move toward the solution. Think of it. Done. Let's see. Now see, complete focus should be on your board. आप बोर्ड की तरफ देखिए अभी completely. कैसे प्रोसीड करना है. So what we do, we put values y equals to 1, x equals to 0 and 2. What we get? Tan inverse 1, okay, which is tan inverse e raised to the power 0 plus c. Now can anyone tell me what is the value of tan inverse 1? And tan inverse e0 is what? Again 1. So can anyone tell me? It is pi by 4. Done. So, and this is also pi by 4 plus c. So c can be written as pi by 4 plus pi by 4 which is 2 times pi by 4 and c is pi by 2. So what we get? Value of c is our pi by 2. Okay. Now we put the value of c now where? In equation 2, which is tan inverse y equals to minus tan inverse h plus c. Okay. Now putting the value c is equals to pi by 2 in equation. In which equation? In equation 2. So what we get? tan inverse y, और क्या लिख सकते हैं इसको हम? माइनस tan inverse x प्लस पाई बाई 2 ऐसे लिख सकते हैं. Tell me. और इसको हम लिख सकते हैं ऐसे tan inverse y प्लस tan inverse x इक्वल्स टू पाई बाई 2 लिख सकते हैं हम ऐसे. Sorry, it is e minus x. Here I did mistake one thing. It is e raised to the power minus x. Okay. All fine. Now lies the main part. Tan inverse y can be written as pi by 2 minus tan inverse e raised to the power x. Now we know that pi by 2 minus tan inverse theta. What we get in inverse trigonometry we have studied already. It always becomes cot inverse theta, and theta is our here ex. So can we write like this? Cot inverse ex. Can we write like this? Now there is also concept of inverse trigonometric function, which is cot inverse theta is always equals to tan inverse 1 theta. This is again the property of inverse trigonometry. So can we write like this? Tan inverse 1 by ex. Can we write like this? Okay. Now the tan inverse both are common on the both hand side, left hand and right hand. we cancel this part, and what we obtain? We obtain y equals to 1 minus ex, which is our required solution. Very good question. Okay. Now take 2 minutes and try to analyze how we approached to this question. Then we move to again next question. Which is a next question was also asked in the CBSE previous year question. It was the part of CBSE, which was asked in 2011, 18, 22, and in various other exams. Okay. Your focus should be here. How we approach, how we use the concept of inverse trigonometry to get our final solution. We try to analyze this part. Then I move towards the next question. आप लोग इसको फोकस करिए, देखिए कि हमने यूज़ कैसे किया ये tan इनवर्स के कॉन्सेप्ट को. ओके. फिर हम नेक्स्ट क्वेश्चन को मूव करेंगे, एंड दिस इज ऑल्सो वेरी इंपॉर्टेंट. So we move to the next question. Okay, now we are moving to the next question. तो हमारा नेक्स्ट क्वेश्चन कौन सा क्वेश्चन है? ये हम पिछले वाला कौन सा क्वेश्चन था? 4th. नाउ वी आर मूविंग टू 5th क्वेश्चन. Which is to solve differential equation one plus y square 1 plus log x dx plus x times d of y equals to 0. Okay, under condition differential equations, under condition x equals to 1 and y equals to 1. Okay, full stop. So can you analyze? आप सोच पा रहे हो कैसे करेंगे इस क्वेश्चन को? हम इसमें भी डेफिनेटली हम वेरिएबल सेपरेट करेंगे, बट इसको कैसे प्रोसीड करेंगे आगे, क्या करेंगे? 1 मिनट के लिए सोचो आप. ओके, नाउ हम आंसर की तरफ प्रोसीड कर रहे हैं. ठीक है, तो गिवन इक्वेशन इज 1 plus y square 1 plus log x dx x dy equals to 0. Okay, which can be written as 1 plus y square 1 plus log x dx माइनस एक्स डी वाई डन। अब फिर हम वही करेंगे वेरिएबल सेपरेशन जो कि हमने पहले के क्वेश्चंस में किया था। ओके, सो क्या करेंगे, लेफ्ट हैंड साइड में क्या है हमारे 1 प्लस लॉग एक्स डी एक्स, नीचे क्या आ जाएगा x आ जाएगा और इधर माइनस डी वाई 1 प्लस स्क्वायर, और इसको हम इंटीग्रेट करेंगे बोथ द साइड्स। ओके, नाउ थिंक हाउ कैन यू प्रोसीड। इसको कैसे इंटीग्रेट करेंगे, ये तो सिंपल है, राइट हैंड साइड वाला इंटीग्रेशन ऑफ 1 प्लस वाई स्क्वायर 1 बाई 1 प्लस वाई स्क्वायर टेन इनवर्स वाई, लेफ्ट हैंड साइड में कैसे मूव करेंगे। सोचो सोचो, इसको तो हम सिंपली लिख देंगे माइनस टेन इनवर्स ऑफ वाई है, which is equals to 1 plus log of x dx। इसको हम प्रोसीड करेंगे अगेन विद द हेल्प ऑफ सब्स्टिट्यूशन। सोच पा रहे हो कैसे मूव करेंगे। इस केस में हम t को जूम करेंगे 1 प्लस लॉग एक्स प्लस 1 और फिर हम दोनों साइड डिफरेंशिएट करेंगे। ओके, so what we get, dt equals to 1 by x dx। क्यों लिखा है ऐसे हमने, क्योंकि log x का डिफरेंशिएशन 1 by x होता है। ओके, और इसको हम नेम कर देंगे इक्वेशन नंबर 1। नाउ we put our values in equation number 1। What we get, इंटीग्रेशन 1 by x dx के लिए क्या लिख सकते हैं हम यहाँ पे dt है ना, और 1 प्लस log x के लिए क्या लिख सकते हैं t। ठीक है, और ये फर्दर इसको हम कैसे लिख सकते हैं, इक्वल्स टू माइनस टेन इनवर्स वाई लिख सकते हैं। और इसका इंटीग्रेशन बताओ, वो बहुत सिंपल है, वेरी सिंपल, विच इज टी स्क्वायर बाई 2 dt माइनस टेन इनवर्स ऑफ वाई, है ना, सिंपल। फर्दर जिसको हम ऐसे लिख सकते हैं 1 of t 1 प्लस log of x स्क्वायर माइनस टेन इनवर्स वाई प्लस, लिख सकते हैं ऐसे। ओके, बट हमने फिर अगेन वही क्वेश्चन घूम के आ गया, जब भी हमें कंडीशन गिवन होगा x इक्वल्स टू 1 या y इक्वल्स टू 1, उस केस में हम c को एलिमिनेट करेंगे। सो व्हाट वी डू, वी पुट, इसको हम नेम कर देते हैं इक्वेशन नंबर 2। वी पुट गिवन वैल्यूज क्या है, x इक्वल्स टू 1 y इक्वल्स टू 1 क्या मिलेगा फिर 1/2 1 प्लस लॉग ऑफ 1 स्क्वायर माइनस tan इनवर्स 1 प्लस सी। इसको ऐसा लिख सकते हैं, इज इट? बट हम जानते हैं, क्या जानते हैं, लॉग ऑफ 1 जो होता है वो 0 होता है, ठीक है। तो इसको हम ऐसे लिख सकते हैं 1/2 1 प्लस 0 होल स्क्वायर, और tan इनवर्स 1 क्या होता है, 5/4 होता है, which can be written as 5/4 plus c. Then this is equals to 1/2 minus 5/4 plus c। और फिर c की वैल्यू क्या आ जाएगी हमारी, हाफ ऑफ 5/4। इस c की वैल्यू आ गई, c की वैल्यू आ गई ना। अब इसको क्या करेंगे, हम इक्वेशन नंबर 2 में पुट कर देंगे, ओके। सो पुटिंग नाउ we put value of c in equation number 2, and what we get after putting, क्या है वैल्यू, हाफ ऑफ 1 प्लस लॉग एक्स का होल स्क्वायर माइनस tan इनवर्स y प्लस सी, ओके। सो वी गेट हाफ ऑफ 1 प्लस लॉग ऑफ एक्स होल स्क्वायर इक्वल्स टू माइनस tan इनवर्स y प्लस 1/2 5/4। गॉट इट। अब आगे कैसे प्रोसीड करेंगे हम, कैन एनीवन टेल, हम इसको ऐसे लिख सकते हैं tan इनवर्स y π/4 प्लस हाफ माइनस हाफ 1 प्लस लॉग ऑफ एक्स का होल स्क्वायर। डन। जिसको कि हम फर्दर लिख सकते हैं y इक्वल्स टू 10 π/4 प्लस हाफ माइनस 1/2 प्लस लॉग एक्स स्क्वायर। हमने यहाँ पे क्या किया, tan इनवर्स को हम इधर लेके गए तो ये बन गया 10 π/4 प्लस 1/2 माइनस 1/2 1 प्लस लॉग एक्स का होल स्क्वायर। ये हमने इनवर्स ट्रिग्नोमेट्री में पढ़ा था, ठीक है। गॉट इट। सो दिस कैन फर्दर रिटन एज y इक्वल्स टू tan ऑफ π/4 प्लस हाफ ऑफ 1 माइनस ओके। इसको लिखने की जरूरत नहीं है, ये हमारा सॉल्यूशन ठीक है, इसको मिटा दो, इतना ठीक है सॉल्यूशन हमारा, दिस इज ओके। ओके, सो दिस इज आवर फाइनल सॉल्यूशन, y इक्वल्स टू 10 π/4 प्लस हाफ माइनस हाफ इंटू 1 प्लस लॉग एक्स का होल स्क्वायर, इतना ठीक है, ओके। दिस इज आवर सॉल्यूशन, दिस इज आवर फाइनल सॉल्यूशन, दिस इज आवर फाइनल सॉल्यूशन। Okay, try to see what we have done in this question. Then we move towards next question. And then I give you one homework. On similar line. और that was also जो कि previous year होगा वो भी question. ठीक है, फाइन, ठीक है इतना अभी तक. ओके, एवरीथिंग ओके. एक क्वेश्चन करेंगे, नॉर्मल क्वेश्चन है पर अच्छा क्वेश्चन है, 3 to 4 मार्क्स में आ सकता है. ये पूछा जाता है, फेवरेट क्वेश्चन है CBSE और ICSE बोर्ड्स का. जितने बोर्ड्स हैं ना हमारे, काफ़ी फेवरेट क्वेश्चन है. मैक्सिमम सैम्पल पेपर में भी इसको देखते हैं हम, जो करने जा रहे हैं नेक्स्ट क्वेश्चन. क्वेश्चन नंबर 6, which is dy of dx 1 plus x plus y plus xy. इस क्वेश्चन को देखेंगे हम. ठीक क्वेश्चन है ये, ठीक है. इसको सॉल्व करना. सॉल्व दिस. इसको हम कैसे प्रोसीड करेंगे? कैन एनीवन गिव द आइडिया? सोच सकते हैं कोई? इसको हम इसमें अगेन वेरिएबल सेपरेट करेंगे. इधर y कॉमन है हमारा, हम इसको कैसे लिख सकते हैं? 1 plus x 1 plus x कॉमन बाहर ले सकते हैं हम. इसको कैसे लिखें और इसको फर्दर कैसे लिख सकते हैं? 1 plus x टाइम्स 1 plus y dy by dx. इसको हम फर्दर कैसे लिख सकते हैं? इसको हम लिख सकते हैं ऐसे, dy by 1 plus y. अगेन वही वेरिएबल सेपरेबल, y plus 1 को नीचे, 1 plus y को नीचे और 1 plus x dx. And then integrating both the sides. Okay. So can anyone tell me what next? So this is integration of 1 plus y क्या होता है? Log of 1 plus y. And this is log of 1 plus x. Okay. ऐसे लिख सकते हैं हम. बस some integrating, sorry, this is not log of 1 plus x. This is x square by 2. तो इसको हम ऐसे लिख सकते हैं, x square by 2 plus c, and c is our integrating constant. अब हम इसको ऐसे लिख सकते हैं, 1 plus y equals to e raised to the power x plus x square by 2 plus c, which can be written as y equals to x square by 2 plus c minus 1, which is our final solution. Okay, this is C. Simple but little bit tricky. Here. Now I will give you the homework question. Homework question. Just wait a minute. Let us choose the question. Okay. Favorite question of various boards and various examination. Important one. It is very important to solve. To solve 3x 10y by dx 1x sin square y dy equals to 0. These are homework question. And I need to solve, everyone to solve. आप सभी लोगों को सॉल्व करना है इस क्वेश्चन को, ठीक है? एंड टुडे सेशन इज एंड ईयर, ओके।